In previous videos, we learned about memory management and process management by the operating system. In memory management, we learned that efficient use of main memory is necessary for the faster loading and execution of programs. In process management, we learned that programs or processes from main memory that need to be executed should be managed properly by storing their information from time when they are created to the time when they are terminated. There is still one aspect of operating system that we will discuss in this video, that is use of CPU or CPU scheduling. CPU scheduling is the act of determining which process from the ready state should be moved to running state in running state. In other words, which process should be given access of the CPU. CPU scheduling falls into two categories: non-preemptive scheduling and preemptive scheduling. In non-preemptive scheduling, a process in running state gives up the CPU voluntarily. That is, a process from running state moves to waiting state to use another resource other than CPU. Or a process has finished executing and it is moved from running state to terminated state. In preemptive scheduling, a running process is removed or preempted by the operating system to favor another process. In preemptive scheduling, a process in the running state is moved to ready state, or it is moved from waiting state to the ready state. Time between a process induction in ready state to terminated state is referred to as turnaround time. There are different techniques used by operating system for the CPU scheduling. We will discuss here three techniques: first come first served, shortest job next, and round robin. First come first served is a non-preemptive technique in which processes are executed in the order they arrive. A process uses CPU until it needs to use another resource. For our example, I have supposed 5 processes, that is, process 1 to process 5, and they are assigned service time or the time they are going to use CPU. If processes don't require another resource, according to their service time, process 1 will finish at 120, process 2 at 220, process 3 at 310, process 4 at 585, and process 5 at 700. So average turnaround time of the processes will be 387. In reality, turnaround time is calculated by subtracting completion time from arrival time of the process, because processes don't arrive at the same time. Arrival time of processes are always different. In shortest job next, process with lowest service time is dispatched from ready state to the running state. This is a non-preemptive approach as well. Processes use CPU until they require another resource. For the same set of processes in ready state, average turnaround time is 395. Notice that for these processes, first come first serve technique is better because average turnaround time is less than that of shortest job next. The round robin technique is a preemptive technique. Operating system establishes a time slice. Each process in the ready state will use CPU for that specific time period or time slice, and will return to ready state until its turn comes again. For the same set of processes discussed previously, we assume that operating system establishes time slice of 60 to execute processes in the ready state using round robin technique. Gantt chart on this slide shows that process 1 finishes executing at 360. Process 2's service time is 100. So at first it uses CPU from 61 to 120, and when its turn comes again to use the CPU, it only requires 40 units to finish. So instead of relieving CPU at 420, it relieves CPU at 400. In the same way, process 5 finishes at 575, process 3 finishes at 705, and process 4, which required longest service time, finishes at 800. Average turnaround time for this technique is 568, which is more than the first two techniques. But this does not mean that round robin is not a fair algorithm. In fact, fairness of scheduling algorithms depends on a specific type of processes. Round robin supports all kinds of processes or jobs and is considered most fair. That's all in this video. This course is intended to provide essential concepts of computer science. If you like this video, make sure to subscribe and press the like button.